Lesson 5, Chapter 2, Lesson 5, Percent of Change. We go back to the essential question: how can percent help you understand situations involving money? And from what we studied in Lesson 1, where we started with percent of a number, Lesson 2 was estimating percents, Lesson 3 was the percent proportion, and the last lesson was all about the percent equation. Some of those lessons included money and how percent can help you understand it, understand situations with the money being involved. Okay, so in this lesson, we are going to be learning a few things, and these two things will be percent of change can be expressed as a ratio, and that the percent of change can be a percent of increase or a percent of decrease. Let's take a look at the real world link and see how this works. So in Speed Racer, the Indianapolis 500 or the Indy 500 is one of the world's great motor races. The table shows the average speed of the winning cars for various years. So if you are not familiar with the Indianapolis 500, okay, it is actually done obviously in Indianapolis. 500 because you actually do 500 laps, okay, around the track, and then whoever survives the 500 laps and is the first to cross the finish line wins. So in 1922, the average speed of the cars is 94 miles per hour. In 1955, it's 128 miles per hour. In 2010, it's 162 miles per hour. Okay, so the first thing we need to do to be able to understand percent of change is we need to write it as a ratio. So if you write the speed of increase from 1922 to 1955, okay, over the speed in 1922, that is a ratio. The speed increase from 1922 to 1955 over the speed in 1922. Then the next thing we need to do is we need to write it, the ratio as a percent, and then we need to round the percent to the nearest whole percent. So the speed of increase from 1922, which is this one right here, to 1955 is actually uh, 34. Because if I am going to add 28, if I am going to subtract 94, okay, from 128, I will get 30, okay, 34. So this is 34, okay. And if you get a calculator, it's 34 divided by 94 multiplied by 100. So this is how we got this, 34 divided by 94. And then we multiply that by 100, we get 36%. So the speed, okay, of increase or the percent of change is actually 36% from 1922 to 1955. How about from 1955 to 2010? So we look at to 1955, which is again, okay, 128, and 2010 is 162. Again, we subtract 162, okay, minus 128, which will give us our speed of increase from 1955 to 2010. And if we do that, the product will also be 34. So this is 34, okay, over 128, okay, and 34 divided by 128, okay, multiplied by 100 will now give us a percent of change of 27%. Now, if you notice, the difference, okay, is 34 for both speed of increase. Now, the question number 3, why are the amounts of increase the same, but the percents are different? Well, very simple. If you look at the denominator, okay, right here, if you look at the denominator, this is 94, this is 128. They're different because the speeds, okay, for the starting years are different. Okay? And that's the answer to that question. Okay, let's take a look at the lesson proper and let's take a look at the key concept here, which is percent of change. So, what is percent of change? Okay, in words, percent of change simply means it is a ratio that compares the change in quantity to the original amount. So, in words, that is what it means, change in quantity to the original amount. If we are going to make this into an equation, this is how it's going to look like. Percent of change equals the amount of change over the original amount. Okay, take note of this. Okay, this is the formula that we will be following, okay, throughout this lesson. That the amount of change over original amount will equal our percent of change. Okay, so when you compare the amount of change to the original amount in a ratio, you are finding the percent of change. Okay, the percent of change is based on the original amount. So we always look at the original amount and we always look at the amount of change. Okay, if the original amount is increased, obviously we call that a percent of increase. If the original amount is decreased, then we call that the percent of decrease. Basically, if the change goes up, it's an increase. If the change goes down, it's a decrease. Okay? If we want to make this into a formula, percent of increase is the amount of increase over the original amount, and percent of decrease is the amount of decrease over the original amount. Again, we are not changing our formula, it's still the same. The only thing that's changing is the amount of change, whether it's an increase or a decrease. But if you look at our denominator, it remains the same, original amount. Okay, let's take a look at example number one and see how this works. Find the percent of change the cost of gasoline from 1970 to 2010. Okay, round to the nearest whole percent if necessary. Okay, so if you look at 1970, the amount is $1.30 per gallon. Okay, and look at 2010, it is now $2.95. Okay, so we notice that since the 2010 price is greater than the 1970 price, this is a percent of increase. What it's saying is that 2010, which is $2.95, is greater than $1.30. So therefore, the price went up. If the price went up, there it is a percent of increase. So step number one, okay, we need to find the amount of increase, which means we need to get our higher price, which is $2.95, and we need to subtract $1.30, and that's exactly what we did. After subtraction, we end up with $1.65. That is our amount of increase. Okay, so now let's find our percent of increase. Our percent of increase, remember, this is our formula for percent of increase, and we're going to use the same thing here. So our percent of increase, okay, which is amount of increase over original amount, okay, and we know that the amount of increase is $1.65. Okay, the original amount is $1.30. Okay, so we have $1.65, $1.30. Remember, original amount is the where it's originated from, so where it started from. So this is the original amount, $1.30. So we have $1.65 over $1.30. We use our calculator to divide 1.65 divided by 1.30, rounded to the nearest cent or hundredths place, will be 1.27. And if we convert 1.27 into a percent, we simply move it two spaces to the right. We end up with 127%. So about 127% is our percent of increase. So basically what it's saying is that the cost of gasoline increased by about 127% from 1970 to 2010. Okay? All right, let's take a look at example number 2. Yusuf bought a DVD recorder for $2.80. Now it is on sale for $2.20. Find the percent of change in this price. Round to the nearest whole percent if necessary. So when you say the nearest whole percent, it's asking to the nearest ones. Asking it to round it to the ones place. Okay? So what do we know? We know that since the new price is less than the original price, okay, remember the new price is 220. The original price is 280. This is a percent of decrease. So what we need to do in step number 1 is we need to find the amount of decrease, and for us to be able to find the amount of decrease, we subtract 280 minus 220, which gives us $60. This now becomes our percent of decrease, okay, which brings us to step number 2, find the percent of decrease. So for us to be able to find the percent of decrease, we follow the formula again, percent of decrease formula, which is the amount of decrease over the original amount. And we substitute the value for the amount of decrease, which is $60, and the original amount, which is $280. We simply substitute that. Hold on, let's see right there. Okay, that's what we get. So we get our calculators. We divide 60 divided by 280 will give us a decimal, and that decimal is 0.21. Okay, 0.21, rounded to the hundredths place. Okay, and then we convert that into a percent. And the way to convert that into a percent is we move the decimal 2 spaces to the right. Okay, 1, 2, and we end up with 21%. So the price of the DVD recorder decreased by 21%. Okay? All right, do the guided problems and see if you understand examples 1 and 2. Now there's another thing that we need to consider in this lesson, and that's what we call the percent error. And in words, when we talk about the percent error is the ratio that compares the inaccuracy of an estimate or amount of error to the actual amount. Okay? And as an equation, it's very much similar to the percent of change. Percent of error is equal to the amount of error, or the difference between the higher and the lower guess, over the actual amount. So again, we follow this formula for percent of error. So we always look to this formula to find out the percent of error. Okay, let's see how this works in this instance. So finding the percent of error is similar to finding the percent of change. Instead of finding the amount of increase or decrease, you'll find the amount an estimate is greater or less than the actual amount. Okay? You've probably done this before, or probably not, but suppose, for example, you guess that there are 300 gumballs in the jar, but there are actually 400 gumballs. So you were given a jar and you were asked to guess. And then your best guess was 300, but the actual amount in the jar was actually 400 gumballs. So the actual amount, okay, is 400 and your guess is 300. That means if you subtract 400 minus 300, that will be your error right there. So your error is the difference between 400 minus 300. So your percent of error is 100 over 400, which is the amount of error, which is the difference between the two, which is 100, over the actual amount, which is 400 gumballs. Okay, so 100 over 400 will actually give you, okay, this will actually give you 0.25. As a decimal, move it 2 spaces to the right, will give you 25%. And that's how you got 25% in this particular instance. Okay, so let's take a look at the next example. Example number 3, our last example, and let's see how this works. Ahmed wants to practice free throws. So he estimates that the distance from the free throw line to the hoop and marks it with chalk. Okay, so Ahmed estimates was 13.5 feet. Okay, that is his estimate from the free throw line to the hoop or to the basket. The actual distance should be 15 feet. Find the percent of error. Okay, so Ahmed thinks when he's shooting free throws, it's only 13.5 feet, but the actual distance is actually 15 feet. So we want to find the percent of error. So first things first, we need to find the amount of error that Ahmed did. So the amount of error is we get 15 feet, okay, minus 13.5 feet will give us 1.5 feet. This is our amount of error. So next step will be doing our find the percent of error. And again, our percent of error is given the formula amount of error over the actual amount. So we are given the amount of error, which is this one right here. Amount of error is 1.5 feet. We are also given, okay, the actual amount, okay, right here, which is 15 feet. So if we substitute that, it becomes 1.5 over 15. And if we again divide 1.5 divided by 15 using a calculator, end up with a decimal of 0.1, move it 2 spaces to the right. Okay, 0.1, move it 2 spaces to the right, 1, 2, right there, will give you 10%. So the amount of error is 10%. Okay, do the last got it problem and let's see if you understand example number 3. And thank you for watching.